Imagine that you wish to process many of the feature classes or raster datasets within a geodatabase. Examining the properties of each feature class individually can be very time-consuming. With Python, you can access properties of your GIS data and have your script make decisions based on those properties. You can also create lists of many different types of GIS objects. Each element in the list can be accessed with a Python loop. In the catalog window, I can see the different feature classes in my San Juan geodatabase in my C data folder. I'd like to make a script that lists the spatial reference used for each annotation feature class. I've loaded my script into Python Win, which is a Python IDE, or Integrated Development Environment. Python Win is included with the installation media for ArcGIS Desktop. Below my script window, I can see the interactive window. I can enter Python statements in this window and have them executed immediately. You will use this window in the upcoming exercises. Because I'm executing my script outside of ArcGIS, I need to begin my script by importing ArcPy. To make my code easier to write and interpret, I'll set a geoprocessing environment that specifies my workspace. I've set this to my C Data San Juan geodatabase. Because my path name is a string, I need to enclose it in quotes. Now that I've set my workspace, I can reference GIS data in this location without the need to include the full path. For long path names, the workspace setting is especially useful. Next, I'll create a list of feature classes in the San Juan geodatabase. I'll create a new variable named fcList. There are many functions that will create Python lists of different types of GIS data, such as a list of feature classes or a list of fields in a table. In the interactive window, I have already imported ArcPy. Now I can use ArcPy functions in the interactive window. I'll use the ArcPy usage function to list the parameters for the list feature classes function. Notice that all of the parameters are enclosed in braces, which means these are optional. If I entered the list feature classes function with no parameters, all of the feature classes of my geodatabase would be put into my list. In this case, I want to create a list of only the annotation feature classes. Notice from the help, the first optional parameter is wildcard. If I look in the catalog window, I can see that all of my annotation feature classes have anno as part of the name. To complete my list, I'll use *anno as my wildcard string. Now that I have all of my annotation feature classes in a list, I want to create a Python for loop that will print the name of each feature class and its associated spatial reference. Each time through the loop, the next feature class in the list will be assigned to the variable fc. To find out the coordinate system of each feature class, I'll use the ArcPy describe function and set the result to a variable named desc. The describe function allows me to load properties of my feature class into a variable. Next, I'll print the name of each feature class followed by a colon. On the next line, I'll print the name of the spatial reference used by this feature class followed by a new line character. I'll run my script. The print statements are output to the interactive window. Scrolling through the list, I see the name of each feature class along with the name of the spatial reference. I can also see that the overview states anno feature class has a different spatial reference from the others in the list. The parameters associated with each list function can help you build a list of exactly the GIS data you want to use in your script. Creating a list of GIS data, then describing each element in the list is a powerful ArcGIS Python workflow.